Three things that are important in Epi. Epi actually is a short word for epitaxy, and at the risk of sounding like my mother, that always reminds people when Greek words find their way into the English language, is from the Greek word epitasso, which means place on top in order. In the case of LEDs, this is the process where near-perfect crystalline material is deposited on a foreign substrate, usually sapphire, and this is the material where electricity is directly converted into light. Because of that process and the epitaxy itself is where the maximum efficacy that an LED can attain is determined. From then on, other processes either extract the light or convert, in most often, blue light into white with the addition of phosphorus. So when we're thinking about Epi, the three things that differentiate Philips Lumileds and we're looking at is efficacy, LOP distribution or performance distribution, and wavelength distribution. Epi efficacy or wall plug efficiency, as it's usually measured in the industry, is of paramount importance because it's a ratio of the electrical energy put into LED that's actually emitted as light. And of course, it sets what the performance of an LED is. In addition, whatever is not extracted as light is taken out as heat. And of course, the higher the wall plug efficiency, the less heat that has to be dissipated, which then sets the limit for heat sinks, for how close the LEDs can be put together, how much energy can be put together, how much light can be extracted. Lumileds has been at the forefront of wall plug efficiency with gains over 7% a year since at least 2006. And this continuous improvement in performance is what has actually have enabled to go from light bulbs like this. I'm holding a light bulb from the Bright Tomorrow competition that Philips won in 2011, where one can have a serialized, custom-made technological marvel of a light bulb, to a light bulb like this, which can be more appealing to consumers and is definitely much more price attractive that one can find at Home Depot. And the switch from this to this has come from gains in wall plug efficiency that enable much more efficient LEDs, much fewer LEDs to be used, therefore the cost can be reduced, and because they're more efficient, less heat has to be taken out, so much more streamlined and familiar to consumers form factors can be used in such a light bulb. LOP distribution or performance distribution is another important metric of Epi quality. In Philips Lumileds, we work hard to not only improve the performance, but also narrow the performance distribution by working on both the process and the epitaxy hardware that is being used to deposit the materials. That leads to very narrow distributions that can meet our customer specification without producing amounts of lower performing LEDs that have to be managed, adding to inefficiencies, increased complexity, and increased cost. Blue LED wavelength distribution is very important because in large part determines the final color point of the white LEDs being made when a phosphor is applied on the blue LED to convert into white. At the temperatures where the epitaxy materials are deposited near 800 degrees Celsius, only a few variations of fraction of a degree can lead to perceptible variations of the final LED color point. Lumileds is working hard with proprietary technologies to be able to reduce this wavelength distribution and be able to translate that to a final white LED distribution that enables solutions like freedom from binning, which basically give our customers the one bin of color point they actually need. Lumileds is the world leader in epitaxy technology in terms of performance distributions, color distributions, and most important, in terms of wall plug efficiency.